Yeah, my screen is visible.
Yes, yeah.
Huh. So we have sent one announcement. You can see in the initial day, and I have also sent in the G space. So invitation to join the advanced algorithm. This one first announcement for this course. So this time, in general, in the previous terms, profs took some of the live session for the course, like this session. But this time, prof is taking the live classes in IIT Gandhinagar, and that the same classes are actually also available at the in the on online basis. So prof shared that one invitation links for that circle. There is one web portal circle, so you can join this link, and time to time you will get all the notification of the live classes, so you can directly join that live classes by the prof. So the same course, this advanced algorithm course, is also running in the IIT Gandhinagar in the off campus students. So
Okay,
you can
so
also Mhm.
yeah, I missed actually to this one. I missed. So how
So no problem actually. So the whatever session are done, that
recorded? Are these
uh,
recorded week one?
yes, recordings are also available. Let me show you that things. You
So
can
we
see na.
need to join using the IIT Madras email ID. Is it? It's
Yeah, that
asking
you
for
can join.
password.
So just put your ITM email ID that you will get entered actually. So here you
Password
can
is same.
password. It is asking for password.
Yeah, join learning labs, right? It's thing.
No, I think not, that not required. Some registration are required. You have to fill the name and all the things. Yeah, login. You have to click your password. Like you have to create the password. That is the not predefined password.
Yeah, we can. Okay, it is creating password. Okay.
Create the password that you have to create for later. So here you can see advanced algorithms. This course is running. So so not this. So Jan to April. Yeah, this. Here, whatever class are done, you can see just click on this Jan to April 2026 and past. Okay, so classes what are already done. So you can see that some topics are already matched with your syllabus. So like Metroid, we have in the week 1 content definition and greedy correctness, and greedy for interval scheduling. So this some of the lecture you will see that are matching with your content syllabus. So, ma'am, asked to us to share this link to all the students of this advanced algorithm course in our program. So you can also join this, and you can also join this live class. If you missed, you can see the recording also of the
So
live
this
class.
live class, okay, upcoming next event it will show. Is it okay?
Ha ha ha. That upcoming, it will show that coming class, and there is a last, you can see that schedule is given, like 17 Feb timing is given, as well as some discuss forum is also there. So where professor is actually posted the things when the live classes will be there, and or you can also ask your query directly to the prof Nildara Misra. Okay, some announcement tab is also there. This one. Okay, so if any class is postponed or something is happened, so ma'am is
So
announcing.
how many classes are done, Atul? Like
So
so
if
many
you
classes.
see in the past class, so past,
Started
uh,
in January 13th. Is it?
yes, it is starting before from our course. So this is not sync with exact our program. No, IIT that campus classes is timing different. Our is different. So whatever is done, you can see the recording, but live class you can join as per the schedule. Okay.
Okay.
So this is the live interaction with the professor you can directly do, and you can directly chat with the prof. You can post your queries. Many of the student, I think I saw some members. So here you can see 65 in our program. That Sarath, there are many student I saw that have already joined, and I'm not sure they are watching the lecture. They are joining the things. But so you can also join. I have posted in the group, but not sure nobody responds actually on that.
I missed this. I don't know. Like I didn't get this message. Unfortunately, I didn't know about this. Okay. Anyway, I got
Mhm.
it now. Thank you.
So you can see this post I have done the starting of the course when this group created. And I
Mm,
have also posted on the discourse as well as I have posted in the announcement on the course page. Three places I have posted. So this is the one thing professor actually have asked to us, and so try to join as well as all the classes with prof is taking directly, and also watch the live session. So these are the recorded thing content we have already. So other than this, there is some reordering of the content in this course. So it may be confused to you because when you are opening this week 1, if you will run a video, you will get that prof is talking about week 2 or previous
yeah, yeah.
week.
I
Yeah, that.
understood. Yes, yes. Some reordering is done. Yeah, yeah.
Yes, so you can see this recap of greedy algorithm. So one of the starting term, this was released as a week 1, but later Prof changed this. So this is just released as a recap the things. As greedy algorithm, you have already done in the PDSA course as well. So
Right.
some of the problems, ma'am, also covered in this greedy algorithm. So you can just recap, and main content is started from week 1. So
Mm-hmm.
week 1, do not just focus on the week things. Okay, so just focus on the week content, whatever we are releasing. So that the things. So first week is basically greedy. Second week we have the DP based dynamic programming. Third week we have this maximum flow and reduction things. So I hope DP you have already seen some that PDSA maximum flow,
Yeah.
that's also covered in week 11, I remember, in PDSA. And week 4 is that PNP. I think this is also discussed little bit in the PDSA. Okay, so this is the content for quiz 1, basically week 1 to week 4. And still we are reordering so that you can see two unit name are week 4, so that we will change it later. But this is the first week content that is finalized. Okay, so first is Metroid and Greedy. So Greedy, just recap the Greedy things little bit, and then we will jump to the Metroid things, this content, and then DP, and then network flow, and then NP, PNP. So both are the reduction things. So that we will cover in detail in week 3 and week 4. Okay, so this is the important thing, and yeah, any other query from your side for the course or anything? Any doubt?
Yeah, week 1 I went to the content.
Hmm.
It is a bit math heavy.
Yeah,
Uh,
it's math
so,
heavy.
like,
So.
yeah, some of the questions I didn't understand actually. Grading assignment also it was a bit difficult to understand. Like with the will the these live classes that professor has taken,
Mhm.
they will they add any value or I some of them I was facing some difficulty in solving questions only. Like
Mhm. No, ma'am will discuss some questions in the live classes that lecture. So definitely that will relate to you. So suppose if you can see the Metroid things, the same things will ma'am will taught in that of campus class also. So that is just like a revision of your that is your revision. Maybe some new problem ma'am will discuss. So that will be the additional things over than this that recorded lecture which you have in the content. So that are the additional resource actually. So ma'am, which ma'am is actually providing. Otherwise, the till the last term, prof was taking live session, but in general, maybe in 2 week one session or maybe in 3 week one session like this, and that session was also not for more than half an hour or 1 hour. So that was also, and we have some recorded. I think you can also see that session on the YouTube. So that is done for this course. But now for this term, ma'am is actually that recommended this live classes. Okay, but yeah, in this session we will conduct this session. So instructor, so and we can discuss the things as Metroid. So I can discuss the practice problems. So that will I think help. Have you solved try to practice problem for the week 1?
yeah, I had tried that.
So let's discuss this. I think this will help to maybe to understand the content of Metroid. These things. How many join? So okay, Roop sir is also there. Okay, hello sir.
Yeah, yeah. Just came.
Okay, so only one is Monish is there.
If we can start, Atul, on the question 5 and 7, last one, if we can discuss that. I got that wrong. Three questions.
This one, this
Mm.
practice question you are talking.
Yes, yes.
Okay, okay. Okay. Okay, so two player takes turn removing. So I hope the question is clear to understand what it is talking.
Yeah, yes.
So thing is here two players we have like P1 and P2. Okay, so two players we have, and we have one graph. So that one graph is there, and somewhat that's are some edge and vertex are there. So one by one, both have the turn, and they are removing the edge. Okay, so player two, player one, so both are removing the edge, and finally, so this is the condition to win here. So player two wins if the edges they remove contains a spanning tree. So suppose if you have graph and like I'm just making the small graph here. So this is A and this is B and C and D. Okay, so this and suppose these four edges are there. Okay, so like E1 you have AB, E2 like AC, and E3 BD and E4 CD. Okay, so four edge we have four vertex here and four edge we have. Suppose this example. So P1 player one and player two can remove the edge from this. So like suppose P1 remove this E1, okay, and then turn is P2. So P2 remove is E2, and this P1 remove E4, and then it is removed E3. Okay, so this is the game actually. Now the question is player 2 wins if the edges they remove contains a spanning tree. Okay, so like the what is the spanning tree for this graph? So so there are four vertices we have. So at least three edges are required to make spanning tree. So I hope this spanning tree idea is clear. Correct?
Yes. Yeah. Mm.
So we required the a connected graph without a cycle. Okay, so for this, so that is represent a spanning tree for this graph. So here the player two wins if we combine the all edge of player two and that make a spanning tree for this graph. Okay, so this is the meaning player two wins if the edge they removed contain a spanning tree of this. Okay, and player one wins if we remove this edge from the original graph, then our graph become a disconnected. Okay, so these are the two conditions is given in the question statement. So and this is the game. So if
Disconnected meaning if the graph becomes two components,
yes, two
right? It
component
cannot
original
be.
graph. Okay, so we will remove this edge from the original graph and our graph should become disconnected. Okay, suppose
Right.
if like this is the E1 and AC. So AC is E2 and this CD is E4 and this is E3. Okay, so suppose E1 if I remove E1, so this is removed, and E4 if I remove, so this is removed. So you can see this graph is now becoming disconnected. So A and C is there. Okay, and another side that B and D is there. So E2 and E3. Now, if I am removing this E1 and E4, now our graph become this one. So this is disconnected. Correct?
Yeah. Yes.
In the same case, now you make the graph using this E2 and E3. So what you are getting? You are not getting like E2 and E3. So E2 is this. Oh, E1. So okay. So A and C. That will remain the same. Okay. So E3. So the same thing. Okay. Same. So this is not making a cycle. So here who wins actually? Here player one wins. Correct?
Yeah, yes.
because P2 is not able to make a spanning tree with the help of the edge that P2 removed. But P1 is actually now able to make a disconnected graph after removing this edge from the original graph. So here player one wins. So this is the actual game. I hope this is clear. Okay.
Yes, yeah.
Huh. So now the thing is, anyone is trying to join. 1 second. Adit. Okay. So where it is that hmm, not this one. Okay. Okay. So now the comes to the question here. So is it true that exactly one player wins this game? In other words, is the following statement true? So it is not the case that after the game has been played, both player can claim a win. So is it possible to that here that both player can win in this thing?
I mean, yeah, in this scenario, it's not true, but
Any
in general,
other scenario? Yeah, in general.
yeah, I don't know. My intuition is it can happen, right? Like both can claim. That's what I'm feeling.
Okay. So thing is, Prof is discussed graphic Metroid in one of the lecture.
Yes, yes. Graphic Metroids are there. Yeah.
So graphic Metroid is covered. So in that graphic Metroid, the thing is here you have one universal. So that universal is just like a set of edge of the graph, correct? So all the E1, E2, E3, that all the edge. And what is the like basis for that Metroid, graphic Metroid? So that graphic Metroid, if we talk about the family, so family is just like all forest that make a spanning tree. Okay, so all the edge set that make a tree for that, spanning tree for that, and basis is a spanning tree. So means any combination of set that make a spanning tree for this graph. So that is called as a basis. Okay, that basis like a spanning tree. If you talk about this family of graphic Metroid, so that are the all forests that and we how we can see that this is a Metroid. So that spanning tree, this one is a Metroid. So like all edge are the that universal, and if you make a family, so all set uh, that make a like that not don't make a cycle. Okay. So any edge like you can take here E1. So one is empty set definitely. So that is one empty set. Another is like single set you can take. So this E1 edge is not making any cycle. Okay. E2 single edge is not making any cycle. So that same things. E3 is also not making any cycle. So set of E4 is not making any cycle. And if you take the combination of any like this E1, E2. Okay. So E1
Yeah.
E1, E2 is also not making any cycle. Okay. Similarly, E2, E3. Any two edge will not make a cycle definitely. Okay. And E3 and E4 is also not making any cycle. And after that, you will get a combination of three. So here in this graph, three edge will also not make a cycle. So like
Yes,
E1,
yes. Mm-hmm.
E2, E3 is will not make a cycle here. Okay.
Yeah, four things will come. Four
Huh.
C3. Okay.
So you have this family. So once you will add that four set, that will make a cycle. Okay. So here this is a Metroid. This contain all the property of Metroid. So this that emptiness property is there. Then heredity property is also there. You if you will take any set, then any subset of that set will also be the member of family. Okay. Similarly, that is also that exchange property is also held in this. Okay, you know about the exchange property. What is exchange property? If we take any two sets, like one is smaller and another is a bigger set. Okay, suppose if I
Yes.
take this one E3 and another set, I'll take about this E1 and E3. Okay, so both are here. The suppose this is like B and this is A. So here length of A is greater than length of B. Okay, and if we just find out the difference of A and B, so that is difference is this E1. Okay, so that may be anything. So but after that, if you combine this difference between the smaller set, okay, so E1 E3, so E1 E3 is also a member of your family. So you will see this type of property, exchange property is fulfilled. At least one of the member will make a combination with this smaller set, and that will be the part of your family. Okay, so means this is called as a like exchange property. So all the property of matroids are held in this graphic matroid.
Yes,
Here,
yes, yeah. Yes, okay.
okay, here so this set actually, which is making a spanning tree here. So this is called as a basis of this. Okay, so this is the maximum edge you can take to make a spanning tree. You cannot make more than this. So this is the maximal.
So
Okay.
what is the basis? I don't think ma'am covered basis.
That
So
is covered in the lecture. So basis is just like a maximal elements of the set. You can independent set you can take.
okay, okay. Yeah, yeah. Okay.
Okay, so maximal independence that set you can take. So what is the size? You cannot take more than this.
Yeah,
So,
maximal number of independent elements that.
yes, yes, yes.
Mhm.
So that is the basis things. So here the basis is actually spanning tree for this. Okay,
Yeah, okay.
you cannot take more than this. And another side is there is a co-circuit thing. Co-circuit thing is there. So co-circuit things, or we can say sometimes bond. So that is the minimum number of edge required to make this graph disconnected. Okay, so that is called as a co-circuit or bond. So there is one theorem in the matroids we have. Any like so any basis, if you're talking about the basis, so I hope you got this co-circuit means. So co-circuit means uh, minimum number of edge required to make this graph as a disconnected graph.
So minimum edges to be removed, is it? To be
Huh.
removed. The,
Yes. Minimum number of edges. Minimum number of edges we need to remove to make this disconnected. So that is
okay.
the things
Hmm.
as a co-circuit.
Okay.
Okay. So that is co-circuit. So there is a matroid theorem we have. So that says that if we have a basis and if we have a like this co-circuit, so definitely some intersection is should will be there in any basis or any like this co-circuit.
Hmm.
So some intersection will be there.
Okay.
Both cannot be completely disjoint. So this is the one theorem. So this question is based on that. So here we are
Right.
talking about that. So here what we are doing, we are just partitioning the edge. So P1 player 1 is selecting some edge and P2 is selecting different edge. Okay, so P2 is trying to make a spanning tree. Spanning tree means basis. Okay, and P1 target is to find co-circuit.
Hmm.
Okay, and but if you see here they are selecting the edge, so there is no common edge can be selected to both if they are removing the edge. Correct? If suppose if P1 is removing E1, so if edge is removed, P2 cannot be removed the same edge. Na? So in their set, both set will be distinct. So there is no intersection between this basis and this co-circuit things in this partition. So intersect is not possible, and that is this is the matroid theorem. So definitely some intersection will be there. So because of that, both cannot be win. If P2 get the basis like a spanning tree, the same time P1 cannot get the co-circuit to make this disconnected, because both are disjoint edge set and there is no intersection between. You can try with any simple graph or any type of graph, you will always see that both player cannot win at the same time.
So so from the theorem, like there is some intersection. So if one gets all the elements, the other can't get because it has
There
some
is no
common.
edge commons. There is no intersection edge actually, because
No, no,
both have.
because of the intersection,
Hmm.
uh, all elements can't be with both of them. It will be to one only one of them. That's what you're
Yes,
saying.
yes. So suppose if P2 got all the S like E1, E2, E2, E3 like this. So this is making basis. So any of the S cannot be part of this because they are just selecting turn by turn. So both cannot be happen, because
Okay,
according
okay,
to
yeah.
the theorem, okay, so that any S should be common.
Okay, okay, yeah, yeah, yeah. Got it. Okay.
Okay. So because of that, this is true. This what claim is given, that is true.
Mhm.
Okay, and you can just think, just you can make some small graph and you can try. So in that case, yeah, that is yes. Now move to the second question: which player wins on a path? So path is actually a like a already a spanning tree. So okay, so if you just see A to B to C to D, like this is the one path. Okay, this is already a spanning tree. Here, to
Path
make
is
this
cyclic, right?
co-circuit, only one edge is required to remove. No, path is not a cycle here. Cycle is different things.
Okay, okay.
Path is just like this. Okay, so A, B, C, D, these things. This is already a forest. You can understand like this.
No, but path is uh
No, that is cycle. Actually, this is a path. Means if you are making some, if you have any graph like A, which is connected to B, to C, to D, so that means one edge sequence of edge from one
mhm.
vertex to another vertices.
So no, I wanted to confirm one thing. Like in PDS, I think like we studied walk. Is it walk and path? Both are different, right? I was a bit confusing. Like in
Walk, I think walk
one node
something can be
one node
repeated.
can repeat, right? One node can
One
repeat
can,
something.
yes, one node can be repeat, but path is just like a sequence of edge without.
Okay, okay.
Okay, so this is already a tree. This is already a forest. Okay,
So
here.
yeah, on this one, I didn't understand this. The some terms were there in assignments which I don't know in lecture I didn't find like forest. This term I
Forest is
didn't
just
understand.
like a, there is no cycle. That is a tree. Suppose we call this like as if this is a forest. Okay,
There
so
is no
any.
cycle that
Ha,
we call that as forest. Yes.
yes. Okay.
And what is stars? Matchings I understood. Matching was covered in the lecture, but
Hmm.
some forest and stars it mentioned in the.
Star, star. In what sense? Star is where it is covered.
No, okay, leave it. I mean, in the assignment, grade assignment, there was one option, stars.
Okay.
But yeah,
Okay. So,
forest, at least forest, if you are saying like
so
it's
forest is graph.
a cycle
If any
graph.
graph is there, and when we have some cycles is also there, and when we break that into a like where there is no cycle. Okay. So that is called as a forest.
So okay, you are saying graph without cycle, that is forest. Any
Yes,
graph.
yes. Mhm.
Okay.
Okay. So here this is path I'm talking. You can make this in any angle. I'm just making this as a in a linear way. So this is already a like a without a cycle, correct? Here
Yeah.
the core
Okay.
circuit is required only one edge, minimal, because we are talking about the minimal set of edge that
Right.
make a
Right. So,
graph as a disconnected. So here
right.
this required only one edge to remove, and then it become a disconnected graph, become a
Yeah.
disconnected.
Understood. Okay. Player one will win. Huh. Yeah.
Yes, okay. And so definitely by the one selection, P1 will win.
Right. Hmm.
Okay, so because of that, answer for this six is win. That player one will be win for the two. And next question is, I think, asking for that
Complete
complete
graph.
graph.
I don't
Complete.
understand what is complete graph here. Like what is
Which player
that?
wins on a complete graph? Okay, so complete graph you don't know. Let me just show you. I have to remove this actually. Okay, so complete graph is just like a graph. I think this is covered in PDSA course simply. So where uh, A, B, and C, and this is D. Okay. So complete graph is the where each pair of the vertices are connected by direct edge, like this.
Okay. Okay. Huh. N into
So
n
that
minus
if you know the V, if V equal to N, so what are the number of edge, maximum edge possible? So N into N minus 1
okay, maximum
divided
edge.
by 2.
Okay. Okay.
Okay. So in this way, we can see this. Okay. So this graph is given here. We have there is multiple spanning trees possible for this. Correct.
Right.
In the
Right. Yeah.
complete graph, multiple spanning tree is possible, and we required only n minus one edge to make a spanning tree. Okay. Correct.
Yes. Huh. Yeah.
Huh. So if you suppose if you are taking the graph of five, okay, so five vertices where the total number of edge will be there. So five into four divided by two, so that two equal to 10. And here to make the spanning tree, we required only four edge. With five vertices, we required only four edge to make a spanning tree n minus one. Okay, and multiple spanning tree is possible. So you can make multiple spanning tree for the same graph with the three edge for this given graph. Okay, so here there is a if P1 and P2 both play, actually P1 and P2. So P2 target is to get to make this spanning tree in n minus one step directly. Okay,
Disconnected. Right. P two.
no,
Okay.
P2 is just make a spanning tree.
Spanning tree. Correct. Huh.
Uh, But here P2 the spanning tree making is easier because there are multiple possibilities there. But yeah, to make this disconnect, this is just like a single option, and it is hard. Okay, so
So
P2 here, if it is removed, start from any edge. So because P2 is, aim is to make this spanning tree to collect the edge which are making to spanning tree, and P2 will not select the edge which is actually making the cycle in their set.
but here I mean, P1 can also win, right? Like P1 can
So
remove, need to
for
remove
this graph, you
three.
see three edges required to make this disconnect. But if you will
Right.
see that bigger graph, okay, so like five edge I saw, so where the 10 edge are possible, so only four is required by the P2 to make spanning, but P1 require more.
Like,
Okay,
no,
because
hmm.
after four edge, all the remaining six edge are making like a cycles in the 10 vertices graph. Okay, so P1 have to remove all the six edge and plus one more edge to make disconnected.
Yeah, okay.
So here you can see here three edge is fine because three edge is required by P2 to make spanning. At the same time, so four edge is required by the P1 to make disconnected.
No, three also works, right? I mean, in any
Actually, yeah. So both are running. Yeah, at the same time. Yeah, three is also fine. Hmm. But thing is, in the bigger graph, less number is required by the P2 to make spanning. Okay, and more number are required by the P1 to make that disconnected. And but there is a multiple spanning trees possible for this. Okay, but co-circuit is limited. Okay, so that is less. So P2 have the easy way to make find the spanning tree before than P1 in this case. So any else if you see that here, so P, if suppose P2 start, okay, and then P2 select like AB, okay. So I'm just making here P2 select this AB. Okay, after that P1 can remove anything, so you can pick any one. So like P1 select CD, so P1 select CD. Okay, and because P2 will always target the edge that are not making the cycle. Okay, if AB is selected, definitely it can pick any other edge also here. So like it is picking AD. So a this AD suppose. Okay, now AB and AB is done, so that AD is done. And if P1 is picking any edge here, so what P1 can pick to make this disconnected?
Yeah, yeah, understood. Like, but theoretically, I mean, theoretically, both require n minus one, right? To, I mean,
No,
P1.
for this graph you feel this because this is just like a smaller graph. But you will feel that if graph is bigger, like 6 edge graph is there, so 6 into 5 divided by 2, so this is like 15 edge, where you required P2 required only 5 edge to make spanning tree, correct? But P1 cannot make that in 5 edge.
Yeah, P1 also can make, right? Like disconnect one.
Cannot,
No,
no,
one
no.
node will have 5 edges attached to it. But I mean, theoretically, I'm saying, but if P1, P2 picks one
No,
connected
you
with
you you
side.
can't make just try it with, okay, uh with 15 like edges, okay, just try to make disconnected in like a 5 steps. You cannot do. Here there is an intention also, so player 2 is also always looking the edge which are not making the cycles, okay, for their selected things.
Yeah, yeah,
So
understand. But
but how the P2 will identify that? So P2 intention, sorry, P1 intention is to just make disconnected two vertices. So if any edge is like
if
connected,
P2, if P2 by any chance, right? Like uh, if they do not take the path, just in the, for example, in this example, right? P2 by mistake they choose BC, uh,
no. So
and
why
GD.
why why P2 will take an edge that is making the cycle?
Yeah, yeah, understood. Okay, okay. I mean, if in
That will
that
not happen.
case,
Na?
uh, yeah, okay.
No, both player are actually playing for win.
Yeah, okay, okay,
So P2 will never be picked the edge that is making the cycle in their set.
okay,
So because
okay.
target is spanning tree, na, so that will so that is the choice for P1. That is easy choice because there are multiple spanning trees possible. But P1 is just looking to make disconnected two vertices. That is the only choice that have.
Yeah, okay. In that case, fine. Yeah. Okay.
Okay, so A and B is given. So just P1 is target is just to make disconnected these A and B. So that is only P1 can look. So that selection the S for P1 is harder, and selection for the S by the P2 is easier compared to that. And P1 will always get the things uh, spanning tree with the that n minus one edge first. So you can start with any smaller example and you can find out this thing. So maybe 4 and 5 and then 6. You will see in any way if you will try, then you will see that this is easier for player 2 to make a spanning tree in n minus 1 steps.
Okay. Okay.
Okay. So because of that, So player 2 will win for the complete graph. Yeah.
Yeah, okay.
Okay. So that was the property for that Metroid. We have this theorem that was the main concept behind this. So some term may be different. So I use this co-circuit or bond things. Ma'am, I'm not sure ma'am, what ma'am is discussed. So that I have this term. So
Closed circuits actually ma'am didn't discuss. She mentioned
ma'am
closed
may.
circuit term, but she didn't explain that actually. But yeah, now,
Okay,
yeah,
okay. So
understood.
just maybe ma'am some use some different terms so that just relate to that the things. Okay, so that was the
Okay.
idea for behind the graphic Metroid for this.
Yeah,
I
okay.
think the
And
initial questions are easy for this practice, correct? I hope you have done all the questions.
yeah, practice practice questions were somewhat I found little bit easy compared to grading assignment. Grading assignment,
So
I didn't
grading
understand.
assignments, you have resource that you can just learn and solve that things you can explore.
Yeah, if you will you be able to explain grading assignment one question, like last question, like it has multiple questions, just uh,
I have to check actually. I'm not sure. I have seen that also. Okay, this one you are
this,
talking.
yeah, just the main question, it has like three questions, right? What
Okay.
paragraph, small paragraphs they have given. Rank of the Metroid.
This
Yeah, this.
rank is also called as the maximal size. What I have discussed that that basis that size is called as a rank.
Yeah, okay, okay. The basis you explained, right?
So what I have just explained the basis. So that is just like a maximal independent set, and the what is the size of that? That is called as a rank.
Hmm. Hmm. Uh, okay. Yeah,
Just
but
try to solve this. Otherwise, we will discuss in the next session, or maybe you can post in the discourse. Just utilize the discourse also.
yeah, okay, okay. And yeah, little bit found this a little difficult
Yeah,
than
math heavy. This
the
is
practice
a little bit
assignment.
math heavy and proofs heavy type of course. So, but yeah, some first 4 week is just a little bit related to the PDSA course. So you have already seen some part of that, and the remaining later part will be completely new after that from week
Okay,
5.
and in the quiz one, questions will be similar to this. Uh,
Similar to this. Like, so whatever you have seen in this practice, just figure out the practice. What is the Metroid, if it is Metroid or not, and what are the properties of Metroid. So that type of question, not too much hard. Okay,
okay.
the same type of questions.
Is there is this meeting getting recorded? Like, can we have any YouTube link for this?
I have recorded this, but I have not live streamed. But I'll upload on the YouTube and will share the link in the that G space.
Okay, thank you.
So maybe some of them you have joined later. So I have just initially I mentioned Prof have shared one that link invite link for their offline classes actually. So Prof is taking the live that offline classes in IIT Gandhinagar, and Prof is also providing the online access for that. So in the initial day we have shared the announcement. If you can remember, if you see in the first announcement, we have also posted in the discourse. So there is an invitation link is given here. So some of the lecture is already done. uh,
Can you please post that link here now in this
that is
chat?
available in the announcement as well as the G space as well as the discourse, all the place it is available.
Yeah, can you please post now actually here? I can
Okay, so that I am posting this complete message.
yeah.
Okay, so ma'am is taking live class in the of IT Gandhinagar for off-campus students, and the same content ma'am is teaching there. So you can also join that class live,
Mm-hmm.
and some class which you have already done and you have missed, that you can see as the recording. So here you can see after getting into this,
Mm-hmm.
so you will see this Jan April 2026 and past. Okay, so past means whatever class have already done, so that recordings are available.
Oh, super.
Okay.
Thank you. Mhm.
So, and whatever class will come actually will done in the upcoming days. So that schedule is given. At that time, you can join directly live class. But when the
Mhm.
ma'am will teach, okay. And later you can ask your doubt in this discuss things. So ma'am is directly Nindara Misra is directly interacting. So many of the student is already joined. Announcement is there. So this resource ma'am have provided to all of you. So you can directly interact with prof through this. And the same course is running in the IIT Gandhinagar. So you will see some of the content or many of the part will same.
Mhm. And this how do we like from our Oracle from this thing we have to sign up like from our
So
ID?
you just sign up from your IIT that email ID. So
Mhm.
there is no credential required. So you have to set up your credential, password or something. After
Mhm.
that, you will enter into this and you will see this all content.
Mhm. How is this course? Like, is it easy or?
Yeah, it is little bit mathematical or proof type of thing. So some little bit heavy. If you are in good in math, and then it will be easy for you. Math and DSA like this. This the combination of both.
Oh, I understand algorithms, but
Mhm.
this maths they use more that is sigma sets and all.
Yeah, so
And
same type of course is theory of computation we have started in this term. So that is also this mathematical like this. Some set theory, discrete mathematics, that type of notations are required to know. Uh, yeah, but you will understand that is also not much difficult. So maybe
mhm,
initial week you will see some difficulty, but you'll understand.
theory of computation, where is it? Like,
That course is started in this term, so that is the first time. So that also use the mathematical notations, discrete mathematical notations. So for
mhm.
this,
That is
otherwise
that's a
the
degree course, is it?
hard degree courses.
Oh, okay. Is there any YouTube link for that?
Yeah, we have the YouTube lecture for the professor. I think that is available on the that main channel, IITMBS degree channel. Or
Oh,
I'll share the playlist link
yeah. If you can
in the
share,
G
that would be
space.
great. Actually, like,
Uh-huh.
I took this course just because of the interest of algorithms in the
Mm.
PDSA, but this math is little making it
Uh-huh.
little.
Yeah. Otherwise, first 4 week is just like the content are approx same. Whatever you have done, like greedy, you have already done. DP dynamic programming is the second week content. That the third week is maximum flow, that reduction, some things which you have seen in the PDSA week 11.
Mm,
Same NP, PNP, that sorry P or NP hard or NP complete, that class of complexity that you have also seen little bit in the week 11 in PDSA. So here, but some proof and that things is there. So little bit over on that.
okay, okay.
Okay, after that, some topic is new like randomized algorithm, approximation algorithms. That are the something new.
Mm-hmm.
Okay. So because of that, join this live classes also of the prof. So that is just like a recap. Just watch the this recorded lecture, and then also join the live classes. So that will be helpful for you to understand the things more.
Yeah, and this has just now started for those guys also, right? So I think
Mhm.
maybe
Yeah.
okay. And do they solve anywhere the programs for this, like any contest programs or anything like that?
No, programming is not there in this course. Like we are not using any code-based things in this course. This is mostly like mathematical proofs and all the things.
Okay, okay.
Okay, we are not using any code assignments or not programming assignment in this course.
Mm-hmm. But there are many algorithms here, right? That's
Yeah,
why.
algorithms, conceptual and understanding and proofs. That's are there only theoretical.
Okay. And that theory of computation is also like that, is it?
That is also the same type.
Oh, okay, okay, okay.
That course is introduced because of that Gate CS content because that is the important course. Right
Oh,
now, theory of computation. Later, we will introduce compiler also, discrete mathematics also in coming terms.
no. Okay. Nice. Nice to know. Thank you.
Yeah. Arup sir, anything you want to add?
No, no, just
Arup sir is handling the theory of computation course right now.
I just enrolled
Sir,
for that.
you took even dynamic programming course, right?
No,
No,
dynamic programming is not a separate course.
No, no, no.
linear
Like some
programming, right?
additional course.
Linear programming, right?
No.
Dynamic
Oh,
programming.
there
Oh,
was a
dynamic
dynamic
programming
programming
workshop,
course
I
by
think.
IITM.
So,
Workshop you are talking about? Workshop.
Workshop.
yeah,
Uh,
Atul has to.
yeah, I took that 2 times. I took that DP workshop. Uh,
Yeah. Okay. It was
yeah,
nice. Yeah. Okay.
Hmm.
Please post the link of even theory of computation, like
yeah. That playlist link I'll post
Thank you.
everything.
And this link also, like the YouTube links.
That I'll upload on the YouTube, and maybe by tomorrow I'll upload. So, yeah.
Yeah. That would be great.
Hmm.
Thank you so much for your effort.
Okay.
It's nice. Thank you.
Okay. Anything else, Archit, from your side? Monesh?
No, Tal, thank you. Thank you.
Okay. Okay. Yeah. Okay. Then thanks. We'll meet the next week for second DP content. Okay. Thanks. Bye.
Chalo, bye. Okay.